Zug Island Redefined, Forging a Future with Hydrogen Steel, a project by Sharni Smith. As we enter an age where carbon neutrality is at the forefront of all major climate policy decisions, we look to our major industries to lead the way in the fight against climate change. One of these major industries is iron and steel. Responsible for 24% of total industry emissions, the production of iron and steel releases more than 3 billion metric tons of carbon dioxide each year, making it the industrial material with the biggest climate impact. This breaks down to about 2 tons of carbon emitted for every 1 ton of steel created. This is largely due to the use of coke plants and blast furnaces in the production process. We cannot, however, simply stop producing these materials. It is forecasted that by 2050, steel demand will almost double from 1,600 metric tons to 2,800 metric tons. This is largely due to how much steel is needed to construct our future infrastructure. Renewable energy, which includes solar, wind, geothermal, and others, is at the center of the transition to a less carbon-intensive society, which also puts steel at the center of the conversation. Steel is required by each of these markets, and without steel, none of the renewable energy sources would be possible. We look to global leaders in the steel industry to see how they are leading the charge to carbon neutrality. In the US, BP is financing the world's first solar-powered steel mill. Companies in Germany, France, and Sweden are all gradually converting their steel production to direct reduction with climate-neutral hydrogen. In Austria, Mitsubishi Heavy Industries will soon complete the world's largest steel plant capable of attaining net zero carbon dioxide emissions through hydrogen. It is clear that steel players across the globe, and especially in Europe, are increasingly looking to green hydrogen for the future of their steel production. In contrast to the traditional methods of steelmaking, which involve converting coal to coke in a process that releases mass amounts of carbon, hydrogen-based steelmaking neither requires a coke oven nor a blast furnace or converter. The raw materials, iron ore and hydrogen, go into the direct reduction furnace and come out as DRI, which is then made into molten steel through an electric furnace to create steel products, with the only byproduct being water vapor. When the hydrogen used in this process is derived from renewable or decarbonized sources, the steelmaking process can become completely emission-free, creating green steel. In order to make hydrogen-based steelmaking a more attainable feat worldwide, the cost of production must be within or close to the cost range of steel made using coal. Experts agree that due to the decreasing prices of green hydrogen and renewable energy sources like solar, hydrogen steel will be cost competitive between 2030 and 2050. As a case study for the Green Steel Initiative, Zug Island was chosen due to its intrinsic history with the industry of steelmaking. Located just south of Detroit, Michigan, the island was historically a marsh wetland peninsula, but became heavily industrialized in 1901 when iron making was brought to the island 120 years ago. Zug Island is located in and contributed to what is known as Michigan's most polluted zip code until it idled all operations in 2020, resulting in the loss of approximately 2,000 jobs to the adjacent community. Despite the pollution and blackened appearance of the island, there are still a number of species that call it home. These include various foxes, lake sturgeon, and falcons. Converting Zug Island to hydrogen-based steel production will allow for the removal of the coal piles that dominate most of the island, resulting in a 300% increase of habitat from 40 acres to 160. This increase in habitat will allow for more trees to be planted across the island, resulting in over 1,000 tons of carbon sequestered per year. Although most of the energy needed to power the steel plant will come from larger solar and wind energy systems across Michigan, the island has the capacity to produce up to 25% of the energy needed to power the facilities. This would be produced through the use of a solar farm, solar train tracks, solar trees, floating solar in parts of the surrounding river, and solar carports. Finally, although Zug Island will never support the amount of jobs it once did due to increased production efficiencies within the industry, the move to hydrogen-based steelmaking will provide around 300 permanent jobs and 500 temporary construction jobs for the surrounding community. Zug Island Redefined has retained most of the existing rail system, excluding a few superfluous lines closest to the expanded habitat. The rail system is used to bring materials onto the island as well as transport finished green steel products. A portion of the existing system to the south of the site will be placed in a tunnel under an earth mound in order to connect the nature trail and the two halves of the island. Of the buildings existing on site, the 3 blast furnaces, coke plant, conveyors, cranes, and cargo dock were all retained and will be converted to aid in the hydrogen-based steelmaking process. The new buildings on site include a materials warehouse to the south, in addition to multiple new facilities that can be used by new green industries. The site circulation retains a northern portion of road in addition to 3 bridges that connect to the mainland. These include a truss bridge that is used solely by the train, in addition to 2 vehicle bridges to the north. The proposed road through the industrial part of the island are more linear in order to increase efficiencies in transportation. The proposed trails are utilized to connect the more natural aspects of the site with the solar field and industry buildings in order to create one integrated system. The proposed trail also moves through the site's multiple restored natural spaces, including forest, wet prairie, and wetland habitats. The most toxic soils on site will be placed in large piles and capped to aid in the detoxifying of the island. This will result in earth mounds. Incorporating hydrogen into the process of steelmaking is necessary to wide-scale decarbonization and worldwide emissions reduction. As hydrogen continues to become readily available, so will the opportunities to make industries and places like Zug Island green. Through the introduction of hydrogen steel, Zug Island is able to redefine the fields of energy, industry, and restoration as we look towards a carbon-neutral future.